I want to congratulate the Vliz and the Vliz people at the occasion of their 10-year anniversary. So let me do that in Dutch, or let me try Flemish. Zo van harte gefeliciteerd met uw 10e verjaardag en nog veel voorspoedige decaden. My name is Jan de Leeuw. I'm presently working at the Nioz Royal Netherlands Institute for Sea Research as well as at the Utrecht University. I used to be the director of Nioz for almost 10 years, and after that I am basically involved with international marine programs dealing with ocean observations, ocean diversity, ocean drilling and climate change. I want to address two topics which have to do with challenges in research for young marine scientists. As we all know, the IPCC is making predictions for our temperature in the year 2100 based on CO2 strategies. And what we also know is that there are major differences in these predictions in terms of temperature. It varies from increase in temperature of half a degree to 6 degrees. So that's a problem. Is it a problem? Well, maybe not. What we can do to validate the models is to go back in time and look for sediments which reflect the greenhouse situation in the Earth. From the sediments we know, and we have reconstructed, that the temperature gradient between the poles and the equator is very low, actually 5 degrees. Meaning that in such a greenhouse world, the temperature at the poles has been between 25 and 30 degrees centigrade, which is very, very high. Now, if we try to back model the situation in the past, this greenhouse situation, with our most advanced models, then the model data don't show at all such a small gradient. They tell us that the temperature at the poles was about 0 degrees and at the equator about 30 or 35 degrees. In other words, we have an immense model data mismatch and we don't have a clue why that is. When I show this picture during the courses in marine sciences, I ask the students, do you know what this is? And they all say, yes, this is sky at night, these are the stars. Well, actually it isn't. It is the microscopic view of one little drop of seawater after having stained the DNA of the organisms present in that drop. And if you look at this picture, you see 2 or 3 big blobs, those are some algae. And then you see the clear dots, those are the bacteria and the archaea, whereas the faint dots represent the viruses. When it comes to the quantities are amazing. In 1 liter of seawater there are about 1 billion bacteria, 1 billion of archaea and 10 billion of these viruses. So the second issue has to do with the microbes, the microbial populations in the sea, and as some of you may know, they regulate, they govern, they rule the world in the sense that they rule the biogeochemical cycles, the carbon cycle, the nitrogen cycle and so on. And because of temperature rise and at the same time a decrease of the pH, so an increase in acidity, these populations are changing and they will change much more in the future to come. And because of that, the biogeochemical cycles will change and thereby the climate. But the major problem at the moment is that we don't have a clue in what direction this will go. I think the key message for the young scientists to try to figure out what we are missing in our understanding of climate and climate change. And I think for the politicians it's very important to know that the scientists cannot reliably predict the future at the moment because of this lack of knowledge. And although I know that they are not happy with that because they have to take their measurements in Copenhagen and other conferences later on, but it's as it is. There is an uncertainty and we have to live with that at the moment.